if we're demonstrating this with students, you might do that as a shoulder barge. Yeah? So you line the kids up, and somebody always amplifies it in the middle, which is an interesting bit of science there, usually one of the lads. And so the amplitude increases over time rather than decreases, but you can show that. And then there's the transverse wave. Okay, transverse waves are cool. Transverse waves, the displacement is at a right angle to the direction of travel. Trans, across. Most students will remember it as a cross-dresser, is a transversal. Okay, that's fine. So, trans means across. If you're doing it with students, then you do this as a Mexican wave. Okay. Do you use Mexican waves when you show this sort of thing with kids? Yeah? Have you got kids to do it holding a piece of rope? Suddenly, one kid in the middle can't be left behind and being watched. Because as they do it, the rope moves and you can see much more clearly. That's a really nice addition that can make it clear. Use a brightly coloured rope, but obviously it shows up nicely in the video too. So a transverse wave, that one, longitudinal wave. Kids say, well, what sort of waves what? Well, sound is a longitudinal wave. When I speak right now, the particles in the air, not the air particles, the particles in the air, are being pushed forwards and backwards by the one behind or in front of them. Okay, being pushed close together or further apart. So that's longitudinal. The problem is, when I speak, or make a sound, you've got to just play this a bit. Okay? That is clearly a transverse wave, but the sound is longitudinal. So we show it, we record it, as if it is a transverse wave, and the kids really struggle to get their heads around that. Okay? So what we need to do is make clear that there is a process where we record a longitudinal wave and show it as transverse. We need to explain that translation. Now, one way you can do it, if you've got access to video cameras, or the kids are allowed to use their phones, whatever, video this as a longitudinal wave with a ruler behind it. So if I have a ruler, or a piece of graph paper maybe underneath, when I do it, and I can slow down the video, I can show the displacement from the starting point, plus 1 centimetre, plus 1.5, plus 1.8, plus 3, yeah, you get the idea? And then, when I plot that on a graph, I get a nice transverse looking wave, even though they know it was longitudinal. Because what we're showing on our y-axis here is displacement from its original point. Forwards this much, backwards this much. So that's the intermediary. Okay. You can get software versions of oscilloscopes. One is Picoscope, I'm sure there are loads more. You can get them for iPads and similar, which will do a lot of the work for you. Okay. The problem is, in some ways, it does too much of the work for you, so the kids don't realise that this is being translated. The other way is one that Rachel, who normally does this workshop up to now, was playing around with last year. They inherited some of the stuff, and we haven't got it to work perfectly. We've got to get there, aren't we? So,
only a model.
Yeah, it's a model. You could, we would suggest, maybe get the students to do this. No reason why not.